Hi everyone. Back with another Excel or Google Sheets lesson in this case. Today we're going to be working with Google Sheets because my main PC with the Microsoft license has actually got a fried power supply, so haven't quite got around to fixing that yet. But we're going to be looking at linear regression today, basically looking at the relationship between two series or variables. We've got our base data set here, and what we're going to be looking at is the effect that temperature has on revenue for this electronics business. And we're specifically looking at, as an example, revenue generated from things like fans and air conditioning units. As you would expect, temperature does have quite an effect on the sales of these types of products. So what we're going to do is similar to what we did last time with the marketing trend analysis. We're just going to Control Shift Alt down arrow to select the revenue series. We're going to drop that in here. I've already done it, but I'm just going to do it again for your reference. Same with temperature, Control Shift Alt down arrow. And we're going to be using a linear estimator function. In Google Sheets, this is linest. And as you can see, the data that it's requesting here is the known data Y, which is your revenue. So let's just select that here. You're just selecting the data, you're not selecting the column title. And the same goes for known data X, which is our temperature data. And then you'll see it mentions calculate B and verbose. These are sort of statistical references, but for now we're not going to go into detail there. All you need to know is that both of these need to be set to 1. So it'll be 1, 1 for the last two variables, and then close brackets. And you'll see this will spit out a little block of data here for us. And what we're looking at here, let me just remove the currency formatting here. What we're looking at here is essentially the temperature coefficient, which, if I had to explain it simply, is basically for every degree change in temperature, what is the effect on revenue? So basically 284 Rand and 15 cents increase in revenue for every degree that the temperature increases. This number here on the right, under column E6, is your baseline coefficient. So I'm just labeling it so you guys can reference back when you need. The baseline coefficient, and you'll see that I've just pasted a little description here in terms of what this number is in cell D7. So you can see it's 0.669, etc. This is the R squared figure. And what this is basically a measure that indicates how much of the variation in revenue is based on temperature. So it's finding basically that there's a 66% relationship, or 67%, sorry, relationship between temperature and revenue in this case. So what we want to do here is quickly just insert a chart from our base set of data. Insert chart. Okay, and you'll see, let's put in a scatter chart here. We want to just make sure that temperature we want to make sure that revenue is on the x-axis and temperature is on the y-axis. And I can see it's not named these correctly, so let me just fix that. The title here should be revenue, and the title here should be temperature in Celsius. Okay, cool. And what we want to do here, just to make sure that everything's good, is go to Customize on the chart editor, go to Series. We want to add a trend line firstly, to find what the trend is within that scatter chart. We're just going to rename the title here, temperature This is revenue. Okay, we've got our trend line. And we also want to add the show the R squared, just to make sure that what we've got in terms of data from our linear estimator function matches up with what Google Charts is seeing on the trend line for the graph. So you can see the trend line for temperature is R squared equal to 0.67, which is just the rounded up figure from our R squared from our linear estimator function. So that all looks good for now. And basically, we can just see that there's a consistent upward trend. As temperature is increasing, revenue is increasing. Obviously, there are some outliers because there's other factors that may affect revenue on a day-to-day basis, whether it's a holiday or mid-month before payday, things like that. But we still have a general trend here. So now what we want to do is look at how do we forecast based on temperature using a linear regression model with a single variable. So we're just going to build out a mock table here, looking at temperatures ranging from 10 to, let's say, 40 with 5-degree increments. Sorry, that should be 35, 40. And then we want to estimate the revenue based on what the temperature is. And how we can do that is basically by saying, open bracket, revenue is equal to temperature multiplied by the temperature coefficient plus the baseline coefficient. Okay, and then all we're going to do here is just make sure we have anchored the temperature coefficient and the baseline coefficient so that that formula drags correctly. The only cell that should change is the temperature that's being selected. So you can see temperature times temperature coefficient plus baseline. Okay, and I think the reason that messed up is because I didn't anchor the correct cells. We want to make sure that I anchored temperature, sorry. So it needs to, like I said, we need to make sure that the temperature coefficient is anchored as well as the baseline coefficient. When I dragged the formula last time, I had anchored the temperature variable, which is incorrect and is why the revenue is decreasing. Okay, that looks much better. So we can see that the temperature is now, the revenue rather, is increasing as the temperature increases, which is in line with what you would expect for an electronics company selling fans and air conditioners. And now what we can do is essentially insert another chart to confirm that our trend line on the initial graph is correct. So I can see the X and Y axes are, swapped around, axes. So what we're going to do is just switch revenue and temperature, making sure that the X-axis is revenue and the Y-axis is temperature. And I'm just renaming the titles because they haven't automatically updated. Okay, so we've got the data plotted there. We can still add the trend line. And as you can see, it's very much lining up to what we were seeing on our initial data set, the revenue versus temperature on the first graph from the base set of data versus what we had forecast using the baseline coefficient and the temperature coefficient with our mock-up table here where we've essentially just looked at temperatures ranging from 10 to 40 with 5-degree increments. So this is the easiest way to look at linear regression when you're purely looking at two series or two variables. And in a future lesson, we're definitely going to dive into um, linear regression across multiple variables. But for now, I think this is a great starting point. And just remember the three figures from the linear estimator function that are important for this are your coefficient, your baseline coefficient, and your R squared. We're not going to confuse the situation with all of these other variables right now. We might get into those at a later stage. But yeah, that's it from me today. Thank you so much for watching. And yeah, there'll definitely be another tutorial coming up shortly. Thanks so much. Bye, everyone.